50%, making it one of the fastest growing roles.
today? So today let's look at LeetCode 35. We return the index. In this case, the index was 2, right? 0, 1, 2. But there's going to be some cases where we do not find the value. In that case, we're going to return the index if we were to insert the value in order. Conveniently for us, the input is sorted. So in this example, 2. Now 2 is not in this array, but we know that in order it would go over here between the 1 and the 3. So in that case, we would have a output array, or a new array of 1, 2, 3, 5, 6. Now the indices of this are going to be 0, 1, 2, 3, 4. So we're going to return 1 because that's the index that we inserted our 2 at, and that's what they tell us in the example. Now your first thought might be, well, since the input is sorted and we're given a target value, then can't we just go left to right and just search the array starting at index 1? Is this equal to 5? Nope. Is this equal to 5? Nope. Is this equal to 5? It is. So we return value 2 because that's the index. So this is actually easier than you'd expect, right? This is the easiest solution. It's not even a bad solution. It's O of n. We didn't need any extra memory. This is a pretty good solution. But my question is, can we do even better than this? Is it even possible to do better than linear time O of n? Is that possible? Well, the hint that they gave us is that this input is sorted. Can we use that to our advantage? Can we maybe do better? Can we get a solution that's log n? And the answer is yes. How are we going to do it? Well, there's a standard algorithm that's called binary search that you may have heard of. And I'm going to show you how to code that up to get the most pointer and initialize it over here. So at index 0, we get a right pointer and initialize it over here. And that index is 3. And now we need to compute the middle because we don't want to from the right and middle. Are we going to move it over there or are we going to move it over there? Since we want to start searching to the right, we're taking the averages of our left and right pointers, and that's going to give us a 2. So now our middle pointer is also going to be at this position, at index 2. And so we check, is this value now our target value that we're looking for? It turns out it is. So we found our solution. We can return index 2. But so what happens if our target value doesn't actually exist in our input array? What if our target value is actually 2? Let's see what happens in that case. Notice how we're still initializing our left pointer here, we're still initializing our right pointer here, and we're still going to compute the middle the exact same way. So 0 plus 3 over 2 is going to be 1. So we can put our middle pointer over here once again. Now let's check, is 3 equal to our target? 3 is not equal to 2. Our target 2 is actually less than 3. So we didn't find our target. But now the only question we have, so now since we know this is not our target, the only question we have is which way do we shift? Are we going to start looking for our target over here? Well, these numbers are even bigger than 3, so they're obviously going to be even bigger than 2. So we can instead start looking to the left. So since we're looking to the left, we don't have to update our left pointer. All we have to do is take our right pointer and then shift it towards the left. And since we don't have to check these values, I'm just going to cross them out because we know they're too big. And now we can have our right pointer over here at the same index as our left pointer. So now let's check. 1, is this our target? It is not. So we didn't find our target. 1 is not the target either, and we crossed out every value. So 2 does not even exist in our input array. So what do we do now? Well, we don't actually need to find the value. We just need to know what index we would insert it at. So since 2 is greater than 1, that means we have to start searching to the right. But we know that we already searched every value to the right, and we also have this arrow going to the left. So where's the result? From the picture, it's pretty easy to see that this is where we would insert our 2. And we would want to shift our left pointer because we want to update our left boundary. So we would say left plus 1 is going to be our return value. So this is kind of a high-level general overview of binary search, and I'm going to code this up. And remember that this algorithm is efficient, at least more efficient than O of n. It's
Don't wanna forget